Welcome to your Tech. In the previous lecture, we learned about the atomic structure, what is a proton, what is electron, and what is neutron. In this lecture, we'll be learning about what is conductors, insulators, and semiconductors. So we know that the nucleus is the center part of an atom and the electrons that will be revolving around it. Let us see the concept of energy level. So as we know that the nucleus is positively charged and electrons are negatively charged, and the electrons moving around the nucleus, they have two types of energies, namely kinetic energy and potential energy. The kinetic energy, it happens due to its motion, and the potential energy, it happens due to the charge on the nucleus. So the energy level of an electron, it is sum of these two energies, that is the sum of this kinetic energy and potential energy. The energy of an electron, it increases as its distance from the nucleus, it increases. Means the first orbit electron will have lesser energy compared to the second orbit electron. Similarly, the energy level of the second orbit electron will be less compared to the energy level of the third orbit electron. This is because of that attraction force, it decreases because of the increase in its distance. Means the orbit one electron, which is what closer to the nucleus, and so the attraction, the force of attraction, which will be more here compared to the other orbits. So in general, we can say that the outermost electron will have highest energy level compared to all other orbit electrons. So the last orbit electrons, it plays an important role in determining the property of a material, whether whether it is a conductor, insulator, or semiconductor. So valence electrons. Valence electrons is nothing but the outermost orbit of an atom. That is, the electrons in the outermost orbit of an atom are known as valence electrons. The valence electrons, it determines the physical and chemical properties of a material. The outermost orbit can have maximum of 8 electrons. That is, the valence electrons will have a maximum of 8 electrons. On the basis of electrical conductivity, the materials are generally classified into 3 categories. As I said, that is conductors, insulators, and semiconductors. Let us see conductors. So in this slide, you can observe that the two materials, copper and aluminum, these are all what the two better conductors as we are using in our practical life. When the number of valence electrons of an atom, if it is less than 4, then the material is usually a metal or a conductor. Let us see the atomic structure of sodium, magnesium, and aluminum. You can observe that outermost orbit electrons or the valence electrons, right? It will be 1 in case of sodium, 2 in case of magnesium, and 3 in case of aluminum. So all they have the valence electron number which is less than 4, that is half of the maximum of 8 electrons. So these are all called metal, or we can call them as conductors. So the next one is insulators. So in this slide, you can observe that the two insulating materials, right? One is what the wood, which is what a better insulator, which restricts the flow of electricity. So all the insulators are restricts the flow of electricity or the flow of electron. and the right side one is mica. And some, based on the applications, in some cases we will call it as dielectrics. So especially in applications like capacitor, these will be known as dielectrics. So the non-metal or an insulator, the valence electrons of an atom is more than 4. So you can see that some examples here: nitrogen, sulfur and neon. So if you see the outermost orbit electrons or valence electrons, the number that will be more than 4. So these are all called the insulators. So the final category is semiconductors. Usually semiconductors will be classified in two categories. One is called intrinsic semiconductor materials and extrinsic semiconductor materials. So when the number of valence electrons of an atom is 4, that is exactly 1/2 of the maximum of 8 electrons, the material has both the properties, that is conductivity property as well as insulating property. Both it will have, and here the valence electrons will be exactly equal to 4. So they will be called as semiconductors, especially intrinsic semiconductors. So the example for the semiconductors are carbon, silicon and germanium. You can see the structure of the carbon, silicon and germanium. You can observe that the outermost orbit, it has only 4 electrons. So as I said, the semiconductor is classified into two categories. One is intrinsic semiconductor materials and other one is extrinsic semiconductor materials. So suppose if we want to make an extrinsic semiconductor, we have to cross one process which is called doping. Doping is nothing but adding impurities to the intrinsic semiconductor materials to obtain extrinsic semiconductor materials. So the extrinsic semiconductor materials are N-type and P-type materials. So this will be formed based on its doping level. So suppose if we are adding trivalent impurities, it is called P-type semiconductor, extrinsic semiconductor materials. And if we are adding the pentavalent impurities, we can obtain N-type semiconductor materials. So you can see this table. So the examples for trivalent impurities are boron and gallium, and pentavalent impurities are phosphorus and arsenic. So if you add these impurities to the intrinsic semiconductors, we can get the extrinsic semiconductor materials. Thank you.